Hello guys, in this video I would like to explain about hypothesis testing, and I will explain the general procedure of hypothesis testing in statistics. And you may know that hypothesis testing is very important and one of the important branch of inferential statistics, which has two branches like interval estimation, or we can say estimation, not interval estimation. So generally we say that inferential statistics has two branches, that is estimation and hypothesis testing. So in this video I would like to explain the general procedure of hypothesis testing in detail, and there can be 6 to 7 step procedure that we can complete the hypothesis testing for a given data. So let's start and that how you can proceed. Okay, so the first step is formulation of your hypothesis. This is the very first step. When you see the problem, a problem is given to you, you need to formulate null and alternative hypothesis. Formulate your hypothesis, and that's you can formulate from the statement of the problem. We will have some problem, but in the coming videos, not in this video, and we will see that how you can formulate the hypothesis. Remember that if you are unable to formulate your hypothesis in the correct way, maybe you will have misleading result at the end of the hypothesis testing procedure. So this is very important. You need to formulate your hypothesis in the correct way, and by the way you can do this from the given problem. There can be some statement which can help you to formulate the hypothesis in the correct way. Okay, now let's start. So there can be a possibility, in the problem that, if you suppose you are testing about, the average value of some specific parameter that we say mu, average value we can say. And remember that this procedure is for one population mean testing. It's not for two or more. So this is for only one, to test about the population mean of a single population, to test the mean value of a single population. So let's suppose that we have a problem that to test the average CGPA of a particular university or of a country, or we can test the average income per capita of a particular country or whatever. So that we can state that the average CGPA of that region, of the student in that region, is equal to mu naught. That is a specific value. That CGPA can be 3 or 3.5 or something like this. And if suppose we are talking about income, that can be a specific value mu naught, and that can be $40,000 per annum or $50,000 per annum and so on. So these values are just mentioned. For example, that this mu naught can be a specific value of mu. So you can formulate the hypothesis that mu is equal to mu naught, that is equivalent to a specific value. So in contrast to that, the alternative hypothesis that will be totally opposite to the null hypothesis, and that's why there is a logic and there is a reason. Because when you are constructing the rejection region and the acceptance region should be disjoint, because there should be no common point, because we need to decide about whether to reject the null hypothesis or accept the null hypothesis, or accept the null hypothesis or accept the alternative hypothesis. We should not have a common region, so that's why this should be opposite to the null hypothesis. So look at this, h naught mu equal to mu naught. The alternative hypothesis should be HA, that is mu is not equal to mu naught. Okay, and that we call two-tailed test, the first one. And maybe you have the hypothesis, you need to formulate h naught mu is greater than mu naught. So in this case the alternative should be less than. And for the last case, h naught mu is less than equal to mu naught. For this case, the alternative, remember this is not, these all or alternative hypothesis, remember, should be A and should be A. So this means that these all are alternative hypothesis, and this should be opposite to the corresponding null hypothesis. So this is the most important and crucial step in hypothesis testing, to formulate the hypothesis in a correct way. And the second step is choose the significance level. Normally, it is given in the problem statement that using at 5% level of significance, 1% or whatever. But if it is not given, you need to choose one of them, or you can choose any other. That's depend on your problem, your search problem, and your requirement actually. So these are the most frequently used significance levels you can choose. And remember that this is very important because I will explain this when we are constructing the rejection region. That in fact, I have done a video on construction of rejection region. So if you want to know in detail, just click on the link given in the description of this video, and you will lead to the video on the construction of rejection region. Because the size of the construction, the size of the rejection region depend on the value of alpha. If its value is high, the rejection region can be large, and if its value is small, the rejection region can be small. So remember, the size of this rejection region depend on the value of alpha, and the direction of the rejection region depend on the alternative hypothesis. We will see this later. Now, the third step is choose an appropriate test, and that's depend on now on the sample size, whether sample size is large or small. An assumption that is normality, whether data is normal. By the way, in hypothesis testing, when using z-test or t-test, we assume that the population is normally distributed if we are talking about single population, and if you're talking about two population or more population, still we assume that the populations are normally distributed and independent of each other. The sample run are independent from each other. So these are some assumptions about z test, t test. But there is one thing more, that if the population variance is known, then we need to use z test, and if the population variance is unknown or standard deviation is unknown, then we use t test. So z test is look like this: x bar minus mu divided by sigma divided by square root n, and that is standard normal distributed with zero mean and one variance 1. And similarly, t-test look like x bar minus mu divided by s, that is per sample variance divided by n square root, and this has t distribution with n minus 1 degree of freedom. And why this is important to choose a appropriate test? This is important because when you are constructing rejection region, you will need to use the table of z when this condition is satisfied, and you will use t table when you are you will use t table when you are this condition is satisfied, the population variance as unknown, and if it is known, you will use the table from standard normal distribution, which is constructed by using standard normal table, and the t table as constructed by using the t distribution. So that's very important and to know about these things in hypothesis testing. Now compute that statistic. So once you decide, that's again depend on the problem statement, whether the sample size is large, data is normal distributed, population variance is known, then you can use z and you can calculate this test statistic and in the fourth step. And if it is not satisfied, this one is satisfied, I mean all these satisfied but not the population variance is unknown, then you can use this test in the fourth step. Now determine the p-value or theoretical value. There are two approaches to test the hypothesis. One is p-value approach and the other is theoretical value approach. In this video, I would like to talk about theoretical value approach, and in the next video, I will talk about p-value, that how we can calculate a p-value. So theoretical value approach compare the test statistic to a well-defined threshold from statistical tables. So that's mean you have calculated a test statistic value here, and then you need to construct the rejection region, that the direction of rejection region mean if mu is greater than a particular value, that is right tail test, this one, the rejection region lie on this side, and if it is less than, the rejection region lie on the left side, and if it is two tail test, the rejection region lie on both sides. I already stated that the direction of the rejection region depend on the alternative hypothesis. Now the size of the rejection region, that depend on the value of alpha. Okay, so now you need to calculate the critical region, and that's depend on alternative hypothesis. So that's look like this, and now you can see if this is single right tail test. This means that this point, this end point is z alpha. And if suppose alpha is 0.05, that is z 0.05, and you can see this from the table and calculate the value of z on this line. If it is z test, if it is t test, then you need to see this region that will be t n minus 1 degree of freedom with alpha that is 0.05. So t, suppose n is equal to 20, so n minus 1 is 19, so this will be t 19 and 0.05. You see this from t table. I will explain t table sometime in the next videos. So you can see this from t table and you can point this value, and then the values greater than this point are the rejection region for this hypothesis. Similarly, you can do for this, but this value should be negative because this distribution has zero mean, so the values on this left side are negative and the values on the right side are positive. And similarly, you can do this. There will be 2 points, by the way. Here it will be z alpha by 2, that z 0.025 and minus z 0.025. You can see this from table, and you construct the two values, and then you say the values less than or equal to this point is the rejection region, and the values greater than or equal to this point or is the rejection region, and the center, that is acceptance region. You can construct this from the table. And by the way, in this approach, in the critical value approach, you convert the probability, the value of alpha, to find the value of z or the value of t test, the t variable, the value of z variable and the value of t variable. So that is, you are going from probability to the value of variable. You determine the value of the variable, that is z or t, from the given probability, that's the value of alpha. But in the p-value approach, we will go from the value of z or t variable to calculate the probability. So these two are the inverse procedure, but will give you the same result at the end. Now make a decision. The sixth step, reject H naught, reject the null hypothesis F. The value of test statistic less than equal to z alpha by 2. If we are using z, if we are using t, we will write t alpha by 2, t n minus 1 n to alpha by 2. And similarly, we will write t n minus 1 n to alpha and t n minus 1 n to alpha if we are using t. So this is only for z, but you can use t if the assumptions, the population variance as unknown. If the value of the test statistic in the fourth step here, when you calculated, is less than equal to minus z alpha by 2 or greater than equal to minus z alpha by 2, like here. This you can see, you can come, this is for a two-tailed test. So this means this is minus z alpha by 2 and this is z alpha by 2. So this is the rejection region on the left side and this is the rejection region on the right side for two-tailed test. So if the value of the test statistic is less than equal to this point or greater than equal to this point, we reject the null hypothesis. That means this hypothesis. And if the value lie in this region, we accept the null hypothesis. And for the other, for the value of for the other alternative hypothesis, for mu less than mu naught, the value of the test statistic, if it is less than minus z alpha, like it should be on this region, this one. Alternative is this one, less than, so this one, the last one in this case. So if it is less than z alpha, you need to find this value from the table. There will be some specific value here. And if the calculated value which you calculated in the fourth step is less than or equal to this value, then we reject the null hypothesis and of course accept the alternative hypothesis. And the last one is value of test statistic as reject H naught if the value of test statistic which you calculated in the fourth step is greater than or equal to z alpha. So this is this one, because this is greater, the alternate is greater. So in this case, this is the rejection is on the right side. You need to see this place z alpha, that is z 0.05 from the table. You will have a value of the z now here, and you have a value of z calculated in the fourth step. Value of z or t, whatever, that's depend on the assumptions. So now you comparing the calculated value With this point, if the value of the test statistic calculated in the fourth step is greater than equal to this value, you reject the null hypothesis and accept the alternate hypothesis. And if the value of the test statistic calculated in the fourth step lie in this region, you accept the null hypothesis. So that's simple. Yes, that's very simple, I think. And then you can draw conclusion. When you do all these steps, you need to draw the conclusion. Interpret the result in the context of the research question. State whether there is sufficient evidence to support the alternative hypothesis. You can decide based, on the result you are having here. So this is all about hypothesis testing, and particularly uh, about one population mean, and we could discuss both cases, that is z and t, because you can use t distribution here, but remember that will be t n minus 1 degree of freedom and alpha by 2, and that will be minus t n minus 1 n to alpha, and that will be t n minus 1 n to alpha. And remember that in the fourth step you need to calculate this test statistic if population variance is unknown. So we have discussed both cases in detail, that how we can use hypothesis testing in case of known population variance, in case of unpopulation variance, when we are concerning to test about the average value of a single population mean. And after this video, we will have some problems in the next videos. Maybe one problem with the known population variance, one with the unknown, and maybe we will consider some, the problem which have different hypothesis, alternative hypothesis, like maybe two tail test and one tail test, and one tail test in this way or in this way. So this is enough for today, I think, and see you in the next video. Ciao.